But it does not come during the growing season. That increase we haven't changed. And matter of fact, during the growing season, the rainfall is more sporadic. Fewer rainfall days, but more total water. Irrigation salesman's pitch. I mean, it's the perfect story. You're gonna have more water available, but you're not gonna get it from rainfall, so you're gonna need irrigation, okay? So that's the discussion that we see as, okay, I haven't figured out how to do that. So we'll go to, I haven't figured out how to make any of them work.
Here, do you want me to just do it for you?
Yeah, oh yeah, forward. Okay, so, next.
Maybe.
As she's looking at that, what I'm going to talk to you about is how to as efficiently apply that water as possible. How to reduce the amount of water that you're using, because the greatest amount of energy that we use in irrigation is to move the water. So if we use the correct amount, don't overuse, we save energy, water, and money. Next slide. Okay, I'm going to click off 3 real easy ones. Take advantage of what God gave you, the rainfall. And what that means is that rainfall, you need to know how much it was to be able to credit it. Not all of our vegetable operations get all of the water that we use. Some of it we are using plastics or mulches that run the water off. But if we don't know how much rainfall to credit, then we're at a challenge. That's a project a young man is working on. Actually, I'm filling in for Brendan today because he's down at the Blueberry Conference in Southwest Fort Days. So 8 rain gauges, 20% deviation. If you get a 1-inch rainfall, one of those reads under 9/10, and one of them reads over 1.1. Okay? The National Weather Service's COCOROS system is this one, and in the background is the Michigan State University's Enviro Weather System. Okay? So if you look at it and you say that I'm either over-crediting or under-crediting by 20% or even 10%, then you have to make that up through irrigation, and that's all water that in reality you wouldn't have to apply if you knew the correct amount. Next slide. So rainfall, just know what that rainfall is. Then here's some easy ones. If you're a center pivot irrigation, and I'll tell you, we're almost 90% of our irrigation is center pivot irrigation, so we spend most of our time on those. But interlocking systems, the concept that if your distribution system shuts down, your water supply should also stop. If one component of the system shuts down, it should all stop. It's easiest on center pivots. We've got systems called interlocking. It's very common if we're putting fertilizers or pesticides through the systems. But basically what it does is if the pump, the injection pump for the fertilizer, or the pivot shuts down, it shuts down all of them. We used to do it with electrical wires, radio signals, and now GPS coordinates and your cell phone all have these components to be able to do that. Next slide. So interlocks, one of the common savings I see is producers that don't have interlocks have a tendency to not get there, shut off the water, even though the machine got to the end of the field. So the picture here has 4 points that the machine comes up to and turns itself off, stops moving. If the water keeps going for an extra half an hour, and you look at that, at those 4 points, we get a total of 2 acre inches of water. That's all the water a 500-gallon minute pump can pump for 2 hours. That's wasted, okay? All we need to do is automate to the point that it shuts the well off at the same time the pivot shuts off. Next one. Oh, and the last of the easy ones. As you get into irrigated areas, and you'll see this more and more, this farm's down near Constantine, Michigan, they have a hard time making profits off of the areas that are not irrigated because of setbacks and requirements. So they tend to stack the irrigation together. Do you notice some overlaps between those? Okay? So those overlaps are all areas that if you don't modify the machine so that one of them shuts off during that time period, then you would double apply. Now, out of 30 years, I've asked groups, help me identify these, because this is an excellent research area. Because instead of getting 6 inches of irrigation water, it's getting 12, 13 or 14 inches of irrigation water, which is some neat things to look at, like pesticides moving and those types of things. But from a standpoint of water savings, making sure the end gun shuts off during this time period, and also putting controls on the last sprinklers so one of those machines doesn't water during that portion of the circle is a time saving or a money savers. Okay, the next things are two harder things: irrigation system evaluation and irrigation scheduling. Okay, system evaluation is knowing that if I want to put an inch on, an inch goes everywhere in that application area. Okay, not half an inch here and 3/4 an inch and then 2 inches over there, and not so it's the amount I want and an even amount. And then irrigation scheduling is the idea of turning the system on when I want the water and when the crop needs it. Next one. So, how do I know? I'm going to go into system evaluations and how uniform we are. How do I know it's time to relook at these? I'd like to tell you, 10 years old, re-nozzle. Okay? If we were in Arizona and Nebraska, the research has been done that we can tell you if the sprinkler package on the machine is 10 years old, it should be re-nozzled. About 2/3 of the irrigation equipment in Michigan is more than 30 years old. Okay? So we're at like 800,000 irrigated acres. We were over 500,000 25 years ago. Okay? And then there's a lot of our equipment never dies. We don't wear it out, so it's used. So there's a lot of equipment out there that needs to be re-nozzled. One of the first things to do is easiest to say, look at the pressure gauge at the center pivot point and look at the diagram of the sprinkler setup within the machine, or there's a prescribed pressure that you should be maintaining. If you're not within 10% of that pressure, it's time to reevaluate your whole system plan, okay? If you had regulators are little things that go under the sprinkler that don't let it get more than a certain amount of pressure. That system needs to operate greater than that pressure. So if they're 15-pound regulators, you're going to run 17 to 20 pounds so that everything gets the same amount. It's a great idea to have a pressure regulator at the far end of the machine also. If not, if you fall short at the far end of the machine, you're going to get less water. Next. The next issue, and we've probably over the last 30 years did a good job, and we got a little lax, and now we're trying to come back. It's always harder to come back. If we go to look at sprinklers and re-nozzling, we should do a flow measurement. Middle of the season flow measurement. Is the machine really getting the amount of water you want, and how much water can be delivered there at a given pressure so that the new sprinkler package can be ordered for that. Every conservation district that's thinking about doing system evaluations probably ought to have a flow meter to do that. If they can't afford to buy it, look for the local dealer that will lend it to you. Dealers have a big opportunity here. Most of these sprinkler packages are between $3,000 and $6,000. Okay, so that's all business that they're doing. To have a $2,000 or $3,000 meter that they loan out is a small expense to make sure that it all gets done right. So that's part of the thing. Next slide. So, somewhere in here I got to talk about this importance of it. If I look at the first span on this 8-tower pivot, it only covers 2 acres, okay? If I look at the last span, it covers 30 acres. Where is it most important for me to be most uniform? Far end of the machine, 30 times more important, or 15 times more important, okay? If I have a pressure problem and don't have enough pressure at the far end, I'm gonna have less water than I want at the area that covers the most acres, okay? Next slide, we'll talk about that. So, what we do, we take 150 Taco Bell cups, pull one every 10 feet on a stake. We run the machine over it. Each of these Taco Bell cups is represented by a blue dot. We measure it in a 500 milliliter graduated cylinder. We enter it into an Excel spreadsheet, and we can see a diagram that tells us where we need to make some repairs, okay? If it is totally flip-flop bad, we just say re-nozzle, start over again. If it has things like this, you say, well, there's some reason this can didn't get any water at all. Okay, and the one adjacent to it's pretty low. So there's probably something not turning that's supposed to be turning, or something blocked, or maybe it's the Renke sign that they use to advertise is keeping the water from getting there. So we want to cure that. Over here, that one actually turned out a young lady didn't want to get wet when she was doing her research project, so she turned the sprinklers off on the last top nozzle, which boy, pretty annoying, because you think about all the research that's done with 3 years later that all was missing that. And then some of the common things are end guns, end gun adjustment. It's one of those tricky little things, but once you get it right, it's good. If it's bad, you over apply and under apply. And then before I talked about not having enough water supply, what we run out of water, the first sprinkler gets what it's supposed to, and then it goes down from there. And then we have this little tool called a end gun booster pump on these center pivots that boosts the pressure at the far end. If you don't have enough water, it just sucks the water out of the pipe, causes a low area, then a high area where the pump is providing, and it goofs it all. So those are all reasons to change. Next slide. That's the Excel spreadsheet. Any meat techs in the room? These meat techs, this was used to be one of the common things for them to do, was to fill out this, each can, listed the milliliters, told you the areas that were under or over applied, and it basically became a repair list that was there. There is a system that they call it Christensen's coefficient of uniformity. This one's 79%. Most of the machines that are re-nozzled will hit the 90% range. Yeah. Okay. Traveler irrigation. We only got one irrigator in the room, if I heard it right. Oh, okay, okay. Yeah, I wondered, because you were giving me that snarl every time once in a while. So traveler irrigation, those are the tough guys. I seen a guy the other day was saying he can get 140 acres covered with one machine. I grew up doing that. During the dry spells, we would try to do a run in the morning and run at night. 10 acres per run, 140. Get an inch on per week. What the biggest issue is the overlaps. If we're throwing the water as far as we should, if we're throwing it too far, we get between first run and second run, we get a buildup of water too much. Usually the opposite happens. We're low and we're under watering the area on the transition between the two. Next one. Drip irrigation. You guys don't feel left out. There's this idea that everything in that area that you put your water on should get about the same amount of water. There's a nice little Dr. Tom Fernandez has a paper out there, and has a procedure for pulling data from certain points, entering it in, and making some determinations. Brendan, the person I'm filling in for, has done several of these, and we tend to see a lot, when we get out here to 400 to 600 foot runs, we tend to see problems happening right here about 2/3 of the way out. That's why we're doing more testing in those areas. But basically, they put together a chart, and it will tell you if you're not supplying enough, it will just dwindle down. You'll be getting 100 milliliters here in 4 minutes, and down here you'll be getting 70. And of course, the crop doesn't look as good at the far end. Okay. So, and I'd be a little leery of when they talk about pressure compensating tape. It does a good job, doesn't totally solve the problem. Good designs can minimize the issues. So if we have that problem where we're feeding it from this side and we're not getting enough down here, we talk about, okay, let's move the main, feed it from the center so that we cut the distances. Next one. So here's a scenario. 140 acre field. Original came out here at 75% Christensen's uniformity. That means that if I put an inch on, you're getting somewhere between 3/4 of an inch and an inch and a quarter out there, okay? We put new nozzles on, we bring it up to 94%. That's sort of the industry standards in that 92, 94%. It costs us $4,360 to do that, and the energy savings because I've now made it more uniform. I don't have to overwater to get the low places to yield what the high places will. The energy savings is about $1,600 a year, so about a 4-year payout to replace those. Okay, I would talk about EQIP programs that are funded. There's 441, 449 that are available to do this for you and pay you to do this, but Michigan has like 0 accomplishment in that. Indiana is even lower. Okay, we had some recap programs that had done well, but we have not, we have a problem that we don't have enough TSPs to write the irrigation plans, okay? And we've talked about that, we're working on it. Right now, I tell you, it makes you money to make the replacement. Don't worry about waiting for the government to make the changes as we come. Next one. There, we're looking for collaborators. I'm trying to work with a group of young people. This is the irrigation team in Michigan. Dr. Young-Suk Dong, the irrigation specialist from Ag Engineering. Myself, split between 2 states. Angie Gratis down in Coldwater, Michigan. And Brendan is actually my son, Lyndon Kelley. I got him through. He got his master's degree, left home, went up to Hart, Michigan, and is working with asparagus growers and other vegetable growers on irrigation efficiency. They have a program, and it's going to fund about 6 more studies. We only offer about $1,000, but they'll come out and do the work, figure out how uniform you are, work with the dealer to make sure the sprinkler package goes on, retest it, look for the distance. What we want to do is do 40 of these so we can say the average increase was this, and this is why we should deserve money for producers to have it done for them, to increase the use of the cost share. Next slide. Get it with me if you want to do one of those. I'll get one of those younger people to work with. So, re-nozzling, get the right sprinkler, okay? I started out, we were throwing water a long ways in high pressure machines. What was wrong with high pressure machines?
Too small of drops.
Too small of drops, and then they'd blow, okay? And then you didn't like the energy, right? Because it took a lot of energy. They were always 60, 70 pounds. So that was the 2 reasons. Then we went down to, let's put the drops on below the machine and bigger water droplets. And now we're back to, let's put them back on the top of the machine, and the new sprinklers that are out will throw further, create big droplets, and accomplish that at 10 and 20 pounds pressure. So the industry sort of responded over the 30 years I've worked. What is the problem with the drops in what we call small wetted patterns? When you have them on top and throw them further, you have a big wetted pattern. The bigger the wetted pattern, the longer the water is applied over. I'm putting an inch on, but did I put the inch on in 10 minutes or did I put it on in 30 minutes? Okay? The longer the time period from the first drop hitting that square foot of ground till the last drop, the better the chance it can infiltrate rather than run off. Next slide. Oh, we're gonna move on to irrigation scheduling. 30 years, 0 accomplishments on my part. If you look at the ag census, and they asked for 30 years, that's what, been 6 ag census, they've asked how you decide when you turn the water on and how much to apply, okay? And when you look at this, feel the soil is still 67%, and yet I find very few producers that dig more than 3 inches down. Okay, yes, 70% of your roots are probably in the top foot, but if you aren't taking advantage of the second and third foot, you're always going to be overwatering. Then they'll say crop condition, 90%. The crop will tell you that it's out of water, but it will tell you after it's showed a reduction in either yield or quality. Okay, it's too late. So we have to do something else. We'd like to have some kind of scientific-based model. That's what I'm going to talk about now. Next slide. Way back in the 70s, we grew crops over the top of a scales. Think of a semi-truck box under the ground on a scales. Okay, we put a row of crop, or the last one I did was Christmas trees. Okay, every time it rains, the scales goes heavier, by the amount of water. Every day as the plant grows, it uses the water and it gets lighter, okay? So the amount of water the plant used that day is the volume equal to the weight that block got lighter, okay? What I do now is always give the water a little more water than the plant can use and run a drain. I subtract the amount of water that's drained off of it from the total, and now I know the optimum amount of water the plant would use. Okay, I've taken away all the stress, we've grown the crop, okay? We've done that internationally on like 400 crops, and we've perfected that. And what they've decided, you can go to the next one, pretty much if you fully get all the sunlight used, we use about the same amount of water. In our area, somewhere between 2/10 and a quarter of an inch. Okay, so that's what I need to be able to supply in a long drought spell, like 2012. I need to get about a quarter of an inch a day down. Notice potatoes, only one that's funny in here is alfalfa. Alfalfa goes way up and then it goes down. Why does it go down? I cut it. The amount of water it uses goes down. Okay, next slide. So we have these systems that are out there, and we want to feed them. If we take a look at pumping capacity, if I wanted to supply a quarter of an inch a day, every 4 days I need to supply an inch, okay? So I need to do an inch in 4 days. A 5 gallon a minute pump per acre will do that. So if I have 100 acres, I need a 500 gallon a minute pump to meet that. So there is a calculation down here for drip irrigation that's there too. But remember, when we're doing drip irrigation, you're not watering everything between the rows. So all we want to do is figure out the actual square feet in the area that you're watering. Next slide, please. If you don't have enough, don't pay attention to this if you're a fruit grower or a vegetable grower. If you're corn and soybeans, there's some optimum times that water really makes money. So if I don't have enough water, don't feed it the other times and feed it when it really has the high increases. In soybeans, that's R3 and on. If I didn't have enough water to go the whole year, if I had like a reservoir program and I would hit it at the R3 and then again at R6. Okay, those are the 2 times, we know that from what they call deficit irrigation work in Nebraska that go out there. What happens if you hit it too soon in June, and so you get bigger plants that use more water and don't yield higher. Okay, so we want to stress them. On the corn, on the other hand, week before tasseling is the most important point. You got to get those seeds started that are become the grain, and then the following 3 weeks. Okay, those are the optimal times. These are not the same time period. So if you're short on water, you grow corn on part, soybeans on the other part, or you use the alfalfa program that we just talked about. Let's grow alfalfa and cut it when the other crops need the most amount of water. Next slide, please. Oh, there's a progression. There's one good thing about getting old. You get to look at the stuff that people that you helped in 1988 through the drought, and then you get to look at the people that you talked to in 2008 and then 2012. And what I found was a lot of those people built systems exactly like we said, with enough water supply, like this original white one. Matter of fact, he could do 6.5. He could go about every 3 days, he could put an inch on in those hottest time periods. But then he gets a little bit greedy and says, well, I'll sell water to my brother that has the adjacent farm. And if you look at the calculation there, now he's right down to my prescribed ideal, 5 gallons a minute, okay? But then we get into there and we start adding some specialty crops in these other blocks, and now all of a sudden I'm more like an inch a week, okay? There's a progression. We put the wells down, we start adding the irrigation, and we end up having less supply, and then we get into this point where we either have to stagger the water, stagger the different crops that have peaks, or put in additional supply. Next slide. So I said, well, we did this for irrigation scheduling purposes. We figured out how much water a plant needs, but we needed a way to make this quick so that we could say, well, how much would that plant have used this week? So they standardized, and almost all the world except Nebraska decided that 6-inch grass was the crop. We figured out on this given day 6-inch grass uses this much water, okay? And then I use a crop coefficient to convert that from 6-inch grass to your crop, okay? So corn, I know off the top of my head, starts at 4/10 as soon as it peaks through. So it uses 40% of what 6-inch grass would have been that day. When it peaks, we're up to 110 or 120%, depending on which state you're listening to. And so it's using more than grass. And then it comes right in here about dent, we start down, okay? Next slide, please. So I have that within the scheduling program for 40-some crops in Michigan. And for most of those crops, I have, like this cucumber, 18-inch depth. You'll also see cucumbers at 12-inch and 36-inch. How deep of a profile are we looking at? So those are out there as tools. I'll show you how. So the next thing is, how do I turn those numbers in? Here's a good paper system. This is the dashboard method. I give these out. I find some 10-year-old ones in old trucks every once in a while. But you can look at here and you can say, well, on a temperature basis, if I was 80 degrees yesterday and I was the week after flowering in soybeans, I used 2/10 of an inch. So that inch I applied will last 5 days. Next slide, please. Same thing for corn, same type of thing. A chart using temperature base. Next slide. Then the next thing we go and say, okay, what if I get that reference ET for grass and do the multiplying myself? And so the National Weather Service has this nice map that comes up here, and it would tell us that down here where Brendan is today at South St. Joe, not today, but on September 9th, it used 1.1 inches that week. The charts come daily or weekly. I usually use the weekly ones. So I'm gonna take that number times 1.2, because the soybeans at that stage use 20% more than grass. And it'll come out that this week I need to apply 1.32. I hope that God gives me at least an inch of rain, and then the remainder I make up with irrigation. Same type of thing. These recommendations are available. We have newsletters or email newsletter that goes out, and once a week this goes out as a corn and soybean, and then a reference crop model. Next one. So some of you are going to say, well, I could do that math. I just get that coefficient chart for the vegetables I grow. I just need to reference ETs. You can sign up starting the 1st of March at Michigan Enviro Weather, and they will text you the last 4 days and the next 5 days of estimated ET, okay? They come in at like 5:32 in the morning. Because mine go bing, bing, bing. I watch 3 stations, and I can get those texts sent to me. Or you can go to the website and pull those in. Next slide. There's a nice little Excel spreadsheet, does all the math for you, and that's available under Michigan Enviro Weather at their site. You can pull in this Michigan Excel scheduler. Okay, next slide. Oh, I did one of my partners dirty. There should be a slide in here right now of this new little handheld app that Dr. Dong's put together. It does all of those things for you in a phone version, okay? So look for MSU Irrigation phone app, okay? Now, back at the Excel scheduler, one of the things it does is an end of season report. It tells you that you should have, by their theory, maintained those water supplies, okay? Notice that this is pretty real world data. Rainfalls come in here as blue lines. Irrigations were 1 inch of irrigations are coming in here as black lines. Notice there's a few times he went over the full mark. In other words, then we would leach down. So back in my old meat days, I'd say those are events that are potentially moving nitrogen or leachable pesticides down. We want to avoid those. But then we want to avoid these because these are days that the corn's rolling up or the soybeans are flipping, telling nature I can't use any more sunlight, can't get enough water to do it. So those are issues there. So that's a nice little chart. A lot of people see that. Does this work? Yep. Nice little study. I think grad students from MSU did this we're at 5 years now. Notice this is basically recommended amount plus 30%, minus 30%. The plus 30% equaled the recommended amount, but you had additional expenses. So it didn't make up for, or it didn't equal. So the recommended amount has shown to be the most advantageous, both environmentally and dollars-wise. Next slide. Need to talk about volumes of water. So far I said, well, you're gonna put on at least 1.32 inch a week. Very few of us are gonna put all that on at one time. Matter of fact, you're probably putting on, you're running every day on vegetables, right? Or every other day? Go next question. Depends. When we are applying water, we definitely don't want to apply more than what the root zone will hold. The root zone has a certain given capacity, and then there's a certain amount of moisture that's in there because I'm not waiting till it's all gone and my crop's wilting. So the more I left, the further down it will go. So that comes into the idea of monitoring through there. The other concept here is we don't want to continuously under irrigate. We want to have some big irrigations so that we get moisture down here, because we remember I need moisture to move the nutrients in that profile to the root system. Okay, so basically we start out the season, our applications are going to be somewhere in that 1/3 to a 1/2 inch at a time. We are not going to wet very far down at all. Okay, in July we're going to move up, June, July we're going to move up to a 1/2 or 3/4 of an inch. In August we may be at a full inch, and then we get into September and we see the end coming, we go to smaller amounts, hoping that we can pump as little of water as possible and hope those fall rains carry us through. Remember, this saves water. It also saves the number of times that you wet the plant. The more times you wet the plant, more chances of disease. Next slide, please. How am I coming on time?
We got about 8 more minutes.
8 more, I better keep going here. So, yeah, I had a hard time. A lot of people feel many small applications were the way to go. And we did some research. We had some things with Dr. I'll think of his name in a thing, the disease specialist over here near Buchanan. And we had fields that had 1 inch of water applied, but it was 4 1/4 inch applications, and it got tar spot terrible. So we started doing some research on that. And basically, we showed drought symptoms and tar spot, which seemed odd. But when you think about it, when I apply water, I'm applying it to a crop, okay, because I'm overhead irrigating. So that crop holds on to a certain amount of water. We know so far that it holds on to about 700, a little less than 1/10 of an inch on a complete corn crop. Big silage corn more, little seed corn less, but about 7/10 of an inch is in that crop. That's 7/10 that never makes it to the root zone, okay? And then the soil surface, it holds about, 7/100 of an inch. Soil surface holds about 3/100 of an inch. So every time I apply water, I only get 90% of a 1 inch application. The first 1/10 is on the surface, doesn't make to the root system. The fewer times I make applications and bigger applications, I don't have to pay that drying cost tax, okay? So if I say, well, I need 5 inches during the month of, I can't remember, August, if I did that as 1 inch and a quarter or 4 inch and a quarter applications, I would net the crop somewhere around 4.6 inches. If I did it as 1 inch applications, I get a little less, about 4.5 inches. But I've wetted the crop just 5 times. If I go down here to 1/4 inch applications, like the tar spot problem field, it had 20 applications and the net water is only 3 inches. 2 inches of water was wasted to evaporation. Next slide. Everything I've talked about applies, most of it applies just to overhead irrigation. If you're a blueberry grower or growing vegetables and you're not interested in watering the whole field because you've invested in drip irrigation, or if you have invested in drip irrigation, I can feed just the plant that I want, okay? So when I do these I've got to convert and say how much of the field. So I may have 40 acres of blueberries, but I've only got 20 acres of actively growing plant that I'm putting water to. Next slide. And here's a swim rack project we did. Couple interesting things there, but basically most producers come down to the point where they figure out how many minutes it takes to apply 1/10 of an inch. So at this project, 42 minutes, put 1/10 of an inch on that strip of ground where we had that crop. And that becomes pretty important, especially in drip, because if you over irrigate, then you push it beyond the root zone down. And since the waters always come from the same point, it creates a preferential flow path. Once it does it once, it comes on a lot quicker. And all of a sudden, a lot of the stuff that Brendan's doing now is blue dye testing, looking at how our performance is. Or should we be looking at 8-inch spacings or 12-inch spacings or 24-inch spacings, and does that make a difference? That's the sprinkler, the emitter spacings on the tape. Does that make a difference on how much water's staying in the root zone? Next slide.
We have about 3 minutes.
3 minutes, thank you. So probably pretty close to the last topic. Some of you would say, well, let's just forget about all those estimations. Let's actually measure the soil moisture that's there. Well, we had a few farmers for years that would soil probe down and look at it, but you've got a challenge in how many fields can you get to. Okay, so then we've got these systems that have came on, and for one scientific reason or another, they can give you a reasonable estimate of how much moisture is in the ground. Next slide. So I'm not going to get into all those, but let's say you have a little meter in there, and that little meter tells you whether it's dry, sort of moist, or moist. Okay? Then all of a sudden I can create that same sort of chart on soil moisture. I can look at, and I can irrigate right from that soil moisture chart that's there. There's a nice paper, bulletin from MSU on irrigation efficiency that goes through this idea of adapting soil moisture monitoring. Extremely favorable for drip irrigation and for fruit and vegetables. So those are the ones that are going to be probably the first to adapt in large scale. Next slide. Yep, if you are one of those people that want to do that hand testing, I found very few people that actually can tell me this has so many % moisture. But almost all of us can say this is wetter than that. Okay? So what you do is create an overwatered area. Put a little bit bigger sprinkler in here, or double up the end of the drip tape at the far end. Now I've got an area that's getting applied more water, and you start looking at the rest of the field compared to the area that applied more water. Now, we started doing this about 8-10 years ago, and the first thing that I've heard back from producers is, you're missing the big point. If the crop looks better where you doubled the water, you underwatered the rest of the field. Okay, so all of a sudden, this idea of creating an overwatered area. Let's see what's next. Last slide. This is the young man that should be talking to you, works out of up out of Ludington. There's he's blue dye testing some blueberries down there near Swimwreck, and there's his address and phone number, Kelley162 at MSU.edu. If you don't want to talk to the younger, faster going generation, then the old guy right here standing in front of you has this phone number and address. So please get those. I do like emails because you can detail your issue or question to me, and I got a lot more material than I do brains, so I can dig out through the material and just try to solve those problems. Any questions?
I'll make a really quick comment really fast, just as far as a resource available for doing some of this irrigation upgrades and all of that. The Ottawa Conservation District has our Farmland and Water Quality Conservation Initiative, which is a mouthful, but we are currently accepting applications for programs and projects or folks who are interested in doing irrigation improvements. We do have capabilities to do irrigation uniformity tests. And those sheets and the sheet that you showed earlier, the Excel form, I know how to fill those out, and we also have a new meat technician starting in a couple of weeks who's helped us out with that, who can also help. So there are resources available through the Ottawa Conservation District.
Tremendous, and I'd be very supportive. We have a training coming up for you guys a couple weeks from now.
Maybe
yeah.
it's with the meat techs.
Oh, yeah, meat techs, yeah.
Okay.
Yeah, we enjoyed, I spent 6 years in the middle of my career working with meat techs.